Okay, so we've completed our shortest routes. We can tick this off. We've done it. Now let's read the next part. So the Hamilton Club would like a network of paths that connects all towns, with the resulting network costing as little as possible. So if we're connecting all of the towns and we want it to cost as little as possible, then it's going to be a minimum spanning tree. Okay. So there's two methods for this, and I'm going to show you both, and you can pick which one you want. There's Kruskal, which gives you exactly the same answer as Prims would. Trying to watch the camera, not what I'm doing. So Kruskal and Prims. Now Kruskal will allow you to list them, and then you can join any nodes anywhere you fancy. Then the more nodes that you connect, the more you have to be aware of not creating cycles, because the whole point of a minimum spanning tree is you want every single node to be activated, but you do not want any cycles. And what I mean by a cycle is that you go from one place to another, and then as you connect them, this would be a tree. But if you then went back on yourself, this would create a cycle. So you mustn't be able to loop round back on yourself. So that would be an error. You would no longer have a tree. So Kruskal allows you to start anywhere and to jump from one node to the other without having to be connected between them. Whereas Prims expects you to activate a node and then be able to move from it. So it depends how your brain works, whether you're quite happy to jump around and keep track, or whether you like a definite kind of, I'm stood here and I can travel here, here or here, but I can't jump all the way over to here until I've got to the point in between. So it's like a stepping stone, whereas Kruskal doesn't need stepping stones. So this is what we're going to do. We are going to take our next piece of information, which is our second table, because our second table mentions the cost of the cycleways between them. And if you reread the question, sorry about the faffing of the paper, you will notice that it's looking at the cost of the network, so it's spending money to create the network. So this is what we have so far. I'm going to do my minimum spanning tree using Kruskal first. And I'm going to explain to the examiner that I know that it's Kruskal by labelling it. So the first thing I'm going to do with Kruskal is I'm going to look down all of my chart and I'm going to put them in size order, starting with the smallest first. Now we're doing a minimum spanning tree. If we are doing a minimum spanning tree, we start with the smallest. And if we're doing a maximum spanning tree, we start with the biggest and we work down. So let's have a look at this. Smallest number so far in this is 460. Are any of these smaller than 460? No. Are any of these smaller than 460? No. Are any of these smaller than 460? No. 360 is my smallest then so far. Anything smaller than 360? No, 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 no. So this one is my number one because that's my smallest. So now what's the next biggest than 360? We've got a 460 here. Let's double check that. Yep, nothing bigger than that. Smaller than that rather. So now we have a 3 here, 480. So 480. The next one, is there any 500s? No. Any 600s? Yes, just that one. So that's 4. Any more 600s? No. Any 700s? Yes. Any more 700s? No. Any 800s? That's 6. And that's going to be 7 because that's 820. Any more 800s? No. Any 900s? No. 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 No, no, but that is a 900, and the last number I wrote was Oh, that's a 5 there. Sorry, it's not very clear, is it? Is that one? Last one I wrote, so that's number 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, cool. Right, any thousands? So we've got 1,000 here, 1,000 here, 1,000 here. So that's the smallest 1,000. So that's going to be 9. Then that's going to be 10. No, it's not. That's going to be 11 because that's going to be 10. Because that's 1050. That's 11. Any more 11s? No. Any 1,200? No. 1,300? No. 1,400. So that's going to be 12. That's going to be 1,400, 1,500, 1,600, 1,700, 1,800. So it's going to be 13. That's going to be 14. Check that I haven't missed any. Yep. And then that's going to be 15, and that's going to be 16. So double check that everything's got a number. Yep. So now what I'm going to do, which I've done already to speed this up, is I've started listing them down in order. So I've just written a list of these going down in order. What's that bit? Need that in a second. Here. So what I've done, nope, that was a practice one. What I've done is I've done a list. Here they are. Let's pop this over so you don't get confused. So what I did is I wrote them down in order, starting with the smallest and ending up with the biggest. So I'm just going to stick this here, and I've noticed that one of my numbers, when I folded it, I've chopped it off, so I'm just going to write it back on. So actually this number here is 720, okay? So what I'm going to do now is I'm going to really quickly do this diagram. So exactly the same as before. What I'm going to do is take my ruler and I'm just going to connect my points up. So we mentioned Hamilton, Cambridge, Tyrrell, and I'm going to put a box around it so I don't get confused with that one. I'm going to cross it through. Matima, Tiawamutu, Pirongia, Takuti, Tapal, Tokoroa isn't it as well? I think that's it. So if you want to be super fast, what you can do is pull up the information that you used before. So that one was, let's use it here. So basically what you can do is just recopy this diagram because it has exactly the same connections. It's just this time what you need to do is just make sure you don't use the same numbers. So I'm just going to quickly copy this over the top, and I've done it in a different colour to help me remember that I'm working with different numbers now, or a different concept. So just quickly connect this up. Nice and fast. Now if you wanted, in your actual internal, if you do a basic network without any numbers on it, I can photocopy it for you to save you time, because you've already drawn it out accurately. I don't need to see that that skill is used repeatedly because you've already proven you can do it. So it's just a waste of your time, really. So if you want me to photocopy anything in your exam, you can ask me, or your internal, in case of habit from coming from England, because everything's called an exam. So I've basically redrawn this exact map, but I'm going to put new numbers on it. So I know that if I follow this, one thing I did do, which is a really good habit, is I've numbered in order from smallest to biggest so that I know I've definitely written every single one down, because I got to 16 here, so I need to make sure I've written all 16 down here. So I'm going to quickly fill this in. Can you see that okay? I hope so. There we go. Stick that down. So let's have a look. Black pen. So Pirongia. So Hamilton to Matamata was 1220. Cambridge was 4600. Next one was 800. It always helps to use a ruler because you'd be really, really upset with yourself if you lost your marks because you accidentally wrote a number in the wrong place. So just don't be afraid to kind of break it down for yourself. Cambridge was 820 and Tyrrell was 630. Okay. Cambridge to Tyrrell was 1920 and to Tyrrell was where am I? 480. Okay, and then Tyrrell to Tiwatmatu was 1830. Notice when you work logically, you can speed yourself up quite massively. So it's just getting into good habits, really. Pirongia to Tiwatmatu. Sorry, it's taking a little bit of time. I just thought you'd probably want to see it actually being done in case you've missed one. So Pirongia is here, and we're going to here, which is 360, and then Pirongia doesn't connect to anything else. And then Takuti to Takuti is 1440. Next one is 1050, so that's going to be, I missed one? I made an error. Tiwamatu and ooh, have I made an error? Tyrrell. Oh, there, you see, that's why you always check. That one should be here, and this one should be 1050. Okay, that was a silly mistake. Okay, so Takuti to it's 4560. This one is 3930, and then that one's 990. So now I should have 1, 2, 3. Okay, so I've got all of my connections done now. So all of my bridges or my arcs are labelled. So now this is what I'm going to do. So I've written everything in order. I've made it all really clear. The examiner can see that I've labelled them in terms of size, and I've listed them in terms of size, and now I'm going to use that list on my diagram. Now, why I'm doing it in both list and diagrammatic form is I want to make sure that I don't create a cycle. Remember, this is a spanning tree, so we must not allow ourselves to be able to go back round on ourselves, or just to basically keep going back in a circle until we get to where we started. We must have to go back on ourselves and then off onto another path. So let's have a look at this. So Kruskals, basically, all you do is you highlight all of your smallest roots and you just keep working up, and you just keep checking for each one that you don't end up with a cycle. So you either tick them or cross them depending whether you're using them or not. So I'm definitely going to be able to draw this one because it's my first one. I can't create a cycle from just one line. So I'm going to have 360. So let's find 360, which is here. And that's going to be my first part of my spanning tree. Okay, next one. We're going to find Hamilton to Cambridge, which is worth 460. So Hamilton to Cambridge is here. Now notice, unlike Prims, I've been able to jump. So although I can't travel straight from here to here, it doesn't matter. And that's the difference. Kruskals, you can jump wherever you like, whereas Prims, you can only go from your last activated node. Now, it doesn't matter what technique you use, you will still get exactly the same answer. So don't worry, go with what feels confident, what you're most confident about and what feels good for you. So Cambridge we've used. Okay, Cambridge to Tiwamatu. So we're going from Cambridge to Tiwamatu. So that's our next route. So straight away, I know there's 2 here that I must not use because they would create a cycle. If I join from here to here, that would create a cycle and that's no use. So I'm going to cross that one through, and then I'm also going to cross it off of my chart and put a big red X next to it. And straight away, if I wanted to really be obvious for the examiner, I would write cycle underneath it so the examiner understands that I realise it's a cycle. Okay, and also this one, so 725. Ooh, did I write it down wrong? Yeah, 725. Oops, that was me, sorry. This is why you double check your work. Yeah, I copied it down wrong, did it in my head. So that's 725. I can't use that one, so I'm going to cross that off as well. Okay, so now I can't use this one, I can't use this one. So the next biggest, I'll make sure I label that it's a cycle. Got too many pens. Okay, it would be, my next biggest would be 820. So I can use 820 because it wouldn't connect and create a cycle. So I can use that one. The thing is now, again, here, this would create a cycle. So I'm going to cross it through and cross it off my list so I know not to use it. So I realise I've made a mistake there, sorry. I've skipped right down to this one, but Mataman Tirau I should have used first. So luckily that doesn't create a cyclops, would have had to start again. So look, just be really careful and slow because I'm trying to rush it so you don't get bored of this video and I'm making mistakes. So 630 was correct, and then I would have then joined this one up afterwards. Okay, so now I need to check the next size, which is 990, and 990 is down here. So I've been able to skip this step. It doesn't matter, I don't have to travel down. I don't have to travel from activated node to activated node, I can skip. So I have used that one. I'm not going to use 1020 because I've already crossed it off, but I might be able to use 1050, which I can because that doesn't create a cycle. So I'm going to go down here and take that one off. Can I use 1120? No, I can't. So I can cross that one off and I can cross it off here. Also, 1920, so 1920 I can't use, so I can cross that one off. And I also can't use 1830, so I can cross that one off because they both create cycles. I'll be able to go around in a circle. Is there any more that have to be cancelled? No. So now I know that 1440 would be my next biggest number, so I'm going to go down here. So straight away this one would create a cycle, so I'm going to cross that one off my list. And also this one would create a cycle, so I can cross that one off my list. So notice I've now ticked or crossed every single one. Okay? So that means my minimum spanning tree is done. Now what I need to do is define it, so explain the roots. So what I would do for the examiner is just copy out all of these in order and I'd add them up as I go. So my minimum spanning tree, I'm just going to shorten it to letters there. I would have 360 plus 460 plus, let's tick them off as I go so I don't miss one, 480 plus 630 plus 820 plus 990 plus 1050 plus 1440, and I'm done. So that's all of them listed now, so let's add them up, and that gives me my final value. So 360, oh, come on, calculator, play the game. 360 plus 460 plus 480 plus 630 plus 820 plus 820 plus 990 plus 1250 plus 4114. Oh, just make sure you type it in right. So I get 7050. So that is going to cost in total. And notice that our table is in thousands. So that's actually my final answer of how much it's going to cost. And that's my minimum spanning tree. So basically the government are going to have to invest £7 million into this network.